Okay, so I've drawn the space-time diagram for in Luke and Hans' rest frame, this frame over here on the left, which corresponds to the four events that take place that's described above, right? So Luke and Han are a distance L apart. They are, in this reference frame, they're stationary, so their position doesn't change in time. There are Luke's world line goes and Han's world line. They both go vertical because again they're not moving. And then the event A we assign to be at time equals 0 and at the position 0 where Luke is. And since the signal is a light signal, it travels with a slope of 45 degrees in this space-time diagram, as I've shown, and it arrives at Han at CT equals, so this is actually also L, okay, CT equals L, and as time tau later, so a coordinate after event number C happens at coordinate, event C happens at coordinate C tau, and then another light signal propagates to Han, and so both of them measure the same time interval. C tau is in the same reference frame. Okay, so now what we want to do is to consider the situation where Lando Calrissian now flies by at a particular velocity in the direction from Dagobah to Tatooine. Okay, and just Luke sends his signal to Han, his first signal, right when Lando flies by, and so the event A happens also at the coordinate at the origin of Lando's boosted reference frame. Boosted meaning it's moving with respect to the LH frame. Okay, and so that event A also takes place at the origin of Lando's oh. Okay, so now in Lando's boosted frame, in Lando's reference frame, he sees Luke moving backwards with respect to him. Okay, and so Luke's world line in his reference frame is actually has a slope, a negative slope, and the slope is actually equal to -1 over beta. Minus because it looks like to Lando, Luke looks like he's moving backwards, and also and 1 over beta because, as we discussed before, world lines in these space-time diagrams have slopes 1 over beta. Now, Han's world line should also have a slope of 1 over beta, but the thing is that the distance between Luke and Han, according to Lando, is actually length contracted because he's moving with respect to that frame. Okay, so again the distance between the planets Dagobah and Tatooine, or between Luke and Han, according to Lando, that distance is an object of length L, a proper length L, but to him it's length contracted by a factor gamma, where again gamma is, as we've defined it in the previous lecture, is equal to 1 over square root of 1 minus beta squared. Okay, it's a Lorentz factor. So this Han's world line has to have the same slope as Luke's, but it's not separated by the same distance as it is in Luke's reference frame. Okay, so there it is. There's Han's world line, and you can see it has the same slope, but the distance between the two world lines that separation between Han and Luke, according to Lando, is smaller. Now, the signal that Luke sends at A has to in Lando's reference frame has to also follow a 45-degree slope because it's light. It has no choice.